Assalamu alaikum, we are Group 11 from Section 4 in Mechanical and Electrical System subject. So in this video presentation we will present our project, which is about the application of mechanical ventilation and electrical distribution system in a single story bungalow. Here are all the group members' name and their matrix number. You can see all of them on the screen. First, I am Moyed Mansour Ahmed Azab Sayadi. I will start from the intro. In this project, you can see our works. We have constructed our one big story buildings that has 5 bedrooms, 3 bathrooms, 1 kitchen, 1 story, and 1 living area that have all the important services that modern buildings need in the construction industry. Mechanical and electrical system are also known as M&D. A mechanical system is any form of service delivered by a machinery. A typical system drawn outside air mixed with the air returns from the entering the system, filters the air, runs it through a heating or cooling coil to get the desired temperature, and distributes the air to the various portion of a structure. In this case of fire, the HVAC, which is heating, ventilation and air conditioning system, also crucial for managing smoke. The electrical system is characterized as an important component in modern buildings, particularly in the utilization capacity of electrical power in structure. The optimum distribution system is one that will provide enough electrical services for to both currents and future expected demands in a cost-effective and safe manner. Our objectives for this project to have more knowledge about the mechanical and electrical system. In mechanical ventilation, to calculate the required volume flow rate, which is Q for the kitchen and bathroom. We should provide details product specification for the selected system. An air conditioning system to identify the interior spaces that are necessary to be installed with the air conditioning system. To calculate the required air conditioning capacity for all the space. Electrical distribution system to identify location for all circuit outlets, switch, lightings, fan and other electrical equipment to be installed on the house. To identify and develop a typical electrical distribution drawing for all the house. That's it. I will pass the mic to another student to complete the presentation. Thank you.
Hi, my name is Mohammed. Now I will talk about the mechanical ventilation of the house. So mechanical ventilation helps to circulate air in the house. It also distributes air properly to each occupied space, and indoor pollutants will be appropriately expelled from the house to provide a healthy indoor environment. The house layout we have chosen for this case study has 1 kitchen and 3 bathrooms. First, we calculate the air flow rate of the kitchen and dining area. So the volume of the kitchen and dining area is 60.87 meter cube. The air change per hour will be 5. Air flow rate will be 0.085 meter cube per second. Hence, we have chosen the Panasonic wall-mounted exhaust fan, model MV25AUM7. The air delivery is 0.24 meter cube per second. On the other hand, for the fan, we have chosen the Panasonic ceiling fan, model FM40DZDDKH. The air delivery is 215 meter cube per minute. For the bathrooms, there are 3 bathrooms in total, and they all share the same sizes. And each of their volume is 8.46 meter cube. The air change per hour is 6. Hence, the air flow rate is 0.014 meter cube per second. So we have chosen the Panasonic wall-mounted exhaust fan, model MV24AUM7. The air delivery is 0.24 meter cube per second. And this is the specifications for the exhaust fan and the ceiling fan. As you can see, for the exhaust fan, the motor rating is 240 volts and the motor power is 25.2 watts to 30.8 watts. For the ceiling fan, the input voltage used is 240 volts and the power consumption is 21 at low speed and 69 at high speed. And that's all from me, thank you.
Hi, Assalamualaikum and Selamat Sejahtera. My name is Muhammad Idham bin Muhammad Damir, DF200-104, and I'll be presenting my part, which is air conditioning system. So air conditioning helps to cool down and maintain temperature in a space of a building. So in the house, we are assumed to be 5 people in the house, and for bedroom 3 and 4, 1 person each, and for bedroom 5 is a guest room that consists of 4 people. So moving on to the example calculation, I'll be using the living room. So first of all, we need to determine the dimension, which is 3.96 meters times 4.27 meters, which is 16.91 meters square. And for the rough estimation, we need to multiply the area to 500. So 16.91 times 500 equals to 8455 kilojoules per hour. So there are 3 factors that need to be considered. So the first one is the shader. So if the room is assumed to be shady, then we need to add another 10%. So 8455 times 1.1% equals 9300.5 kilojoules per hour. The second factor is the number of people. So if there is an exceeding of more than 2 people, then we need to add 633 kilojoules per hour per person. So in this house there are 5 people, so there is an extra 3 people in the living room. So 633 times 3 equals to 1899 kilojoules per hour. Factor number 3 is the light. So this is the formula. Rated weightage time hours of usage over 1000 times 3600. So as there are 8 light points in the living room, so 8 times 12, assuming that each light point is 12 watt, times 8 hours of usage over 1000, and then multiplied to 3600 is equals to 2764.8 kilojoules per hour. So we summarize all of the numbers and we can get 13,964.3 kilojoules per hour. So the needed amount of horsepower is 1.5 horsepower, and this is the recommended air conditioning to be used for the living room. Thank you.
My name is Amir bin Nazri with number 3 DF200-165. So I will present about the electrical plan for our project. So as we all know, the electrical plan is also include the mechanical ventilation, the air conditioning system, and of course the electrical distribution system itself. So we go to the legend, which the position for each M&E system. So first of all, for the lighting point, it's about 53 points for this house. So for the 30 ampere and 15 ampere plug point, is about 19 and 6 plug point within this house. So for the one-way switch point, it's about 26 points. For the electrical meter box and also the distribution box, it's about 1 point for each component, as we can see in the front of this house plan. So for the air conditioning and also heat compressor, is about 6 points for each component. And next is about the exhaust fan is in 2 points within the bathroom. So last but not least, kitchen hood exhaust is about 1 point at kitchen. And lastly, all wiring can be concealed within the wall house. So that's all from me.
Hi, my name is Chong Singh. Now I want to present the electrical distribution drawing of this project. This is the electrical distribution drawing with single phase. This is the energy supply. This is the cut-off speed with neutral ring. This is a DMB meter. This is the ECLB with 100 mA. This is the cut-off fuse. This is the SPD. This is the 60 ampere of the MCB, which is the milliampere of the circuit breaker. This is the 40 ampere of the RCCB, which is the residual current circuit breaker. And this is the 63 of the RCCB. So as you can see, with the 40 ampere of the RCCB, they have the 6 ampere of the circuit breaker with the PVC pipe with 2 times 1.5 mm square to control the 5 lining point plus 1 ceiling fan. And this 4 is same. This is the 6 ampere of the circuit breaker with 2 times 1.5 PVC pipe to control the 5 number of the lining point, and this 6 is the same. This is the 20 ampere of the circuit breaker with 2 times 4 mm square PVC pipe to control the air conditioner with the 1 horsepower. This is to control living room, master bedroom, bedroom 2, bedroom 3, and this is the 6 ampere of the circuit breaker with 2 times 1.5 PVC pipe to control the 2 number of the exhaust fan points and 1 number of the kitchen of the hood exhaust. This is the 6 ampere of the circuit breaker of about the spare line. For the 63 ampere of the RCCB, this is to control the socket. This is the 32 ampere of the circuit breaker to control the 5 number of the 30 ampere socket with the PVC pipe 2 times 2.5 mm square, and this 3 is same. This is the 32 ampere of the circuit breaker to control the 4 number of the 30 ampere of socket, and this is 32 of circuit breaker to control the 3 number of the socket, and this is the 32 of a circuit breaker to control the 2 number of the 50 ampere of socket, and this is the spare line with 32 ampere. Next is to choosing of miniature circuit breaker MCB for each application circuit in this housing. A miniature circuit breaker MCB is an automatically operated electrical switch. They are designed to trip during an overload or short circuit to protect against electrical faults and equipment failure. MCB with 32 ampere typically used for power circuit or socket. 32 ampere of the MCB is sufficient for switch off the electrical circuit for socket to prevent damage to wire and to avoid the risk on fire once a fault is detected. Besides that, 6 ampere of the miniature circuit breaker is a standard lining circuit that chooses as the circuit breaker in this housing. This is because the maximum combined voltage of the bulb can be run off the circuit with these sizes. Air conditioners are notorious for their high energy demands. A 20 ampere of the miniature circuit breaker is more suitable for air conditioner to prevent the short circuit. That's all from me. Thank you.
General conclusion, we achieved all our objectives successfully by choosing the building plan for our project, which is 1 big story building that has 5 bedrooms, 3 bathrooms, 1 kitchen, 1 store and 1 living area. We were successfully to have all the required services that we need to develop the mechanical and electrical system for our building's components placed in the building itself by doing a details analyzing on all the services system. Throughout the entire project, we learned that the value of understanding how 2 aspects of building services works and how to translate our understanding into description and diagrammatic form that will help us as a civil engineering in the future. Thank you for listening. That's all for our presentation.